Hello, this is Mrs. Ringrose, and we're continuing our knowledge of all the trig functions. So this video aligns with chapter 5.4 in our online text, but we're in unit 3. And our goals is that we're going to apply all the 6 trigonometric functions to evaluate. And those functions are sine, cosine, tangent, cosecant, secant, and cotangent. And then if we have time, we'll get to trig identities, although that might be a second video. So these are the 6 ratios, and we learned that the sine function is written sine of theta. And looking at this picture to the left, we have, the part of the unit circle or any circle that we've seen before with a reference angle labeled as theta. And then we know the radius of a circle, we know the y-coordinate, the x-coordinate. So sine of theta is going to be equal to the y value over the radius. A cosine theta is equal to your x over your radius. And your tangent is one of your new ones. Yay, new guys. So we write this as tan theta, and your tangent is actually equal to your y value. This is the ratio of your y value divided by your x value. And your cosecant is actually written like this. And the ratio for cosecant is your radius divided by your y value. And the ratio for your secant is equal to your radius divided by your x value. And then lastly, your cotangent of theta is equal to your x value divided by your y value. So you might notice that we haven't really explored tangent yet, but you might notice that the cosecant is actually the reciprocal of your sine, and your secant is the reciprocal of your cosine, and your cotangent is the reciprocal of your tangent. So we are going to write down some of the trig identities, because these are the reciprocal identities. Any identity is a statement where it's going to be true for all values of inputs. We learned one already, at least one, right? And that's sine squared theta plus cosine squared theta equals 1. Or maybe it was the other way around, cosine squared theta plus sine squared theta equals 1. Either way it works. And so a couple other ones you should be aware of is that your tangent theta equals 1 over your cotangent theta, because it's just the flipped. And also, it's equal to sine theta over cosine theta. So all those 3 ones work. They're all equal to each other. Your cosine theta is equal to 1 over, or actually I'd want to write this the other way around. Not that it's wrong like that, but your secant theta is equal to 1 over cosine theta, and your cosecant theta is equal to 1 over sine theta, and vice versa. All right. So what are you supposed to do with all these? Well, you're going to use these to evaluate exact values of all of our functions. So for instance, if you were asked to evaluate the tangent at 45 degrees, you would do it like this. So you could start by knowing that the tangent is equal to the sine of 45 over the cosine of 45. And then you throw in your values. Because at 45 degrees, the sine is that, and the cosine is that. And obviously, that's going to be equal to 1. And you can get these values again off our reference sheet, or maybe you have some of these memorized already. All right, to find the secant of 5 pi over 6, you might recognize that the secant of an angle is equal to 1 over the cosine of the same angle. And 5 pi over 6, the cosine of that, is negative radical 3 over 2. So then we want to flip that fraction, 2 over negative radical 3, And then when I move the negative to the top and rationalize the denominator, it's going to be negative 2 radical 3 over 3. Hope that makes sense. Right? And here's one more example. If you want to pause me and give it a shot before I get started, that's a good way to learn. So I know that the cosecant is 1 over sine. And I know that my sine at 7 pi over 6 is going to be so when I evaluate the sine of 7 pi over 6, I get negative 1/2. And I simplify this fraction, my answer is negative 2. Okay. All right. So guess what? We do have time to go over some trig identities. So using trig identities is basically you're given either something with a lot of trigs functions inside of it, and the goal is to use substitution as often as possible to make it look more simplified. So maybe less fractions or less squared, so something that just like simplifies it down a little bit. So that's one way to use trig identities. The second way to use trig identities is to prove that two sides are equal. And then another thing that we could do is actually create our own. I guess that's a thing. So, but you cannot use properties of equality yet because you do not know. So for instance, the second question is asking you to prove that they're equal. So properties of equality are things like multiplying both sides by the same number, dividing both sides by the same number. You can't use that unless you've proven that they're equal. So you're just working on one side at a time. So that's why I like working on the first problem. Simplify secant theta over tan theta. It's not set equal to anything, so we don't fall into that trap. Basically, we have to work with what we know and see if we can get it simplified down a little bit. So I know that secant is equal to 1 over cosine. So I'm going to substitute that in. And I know that tangent is equal to sine theta over cosine theta. And then by taking the reciprocal of the bottom, I now have cosine theta times cosine theta over sine theta. And these two can cancel out. And I'm left with 1 over sine theta. So you would think that you're done because you got to cancel things out, but you're not because 1 over sine theta is a function that we now have. It's called cosecant. So we simplified secant theta divided by tangent theta into cosecant theta. And actually what we did was we created our own identity. If secant theta over tangent theta ever shows up again, you know that you can just substitute that with cosecant theta if that's going to help your problem. All right, moving right along. So now we're asked to prove this one. Now to get rid of that fraction, I can't just multiply both sides by cosecant alpha because I don't know that they're equal. I'm trying to prove that. What I want to do is simplify the left side down. So I'm going to write this down because it's so important. All right. You can work both sides if you think that that's going to help, but generally you want to work on the side that looks more complicated. So 1 plus cotangent alpha, the first thing I might do is change that. And I don't know if I'm going in the right direction yet because a lot of this you have to work and then erase because you can substitute a lot of things in here and you want to make it go a certain way. But there's no harm in changing cotangent into cosine alpha over sine of alpha. And that's all divided by 1, not 1. That's all divided by 1 divided by sine alpha, right? Because the cosecant is equal to the reciprocal of sine. Now what I could do is multiply the numerator by sine, because I'm going to bring up that denominator and take the reciprocal of it. So I have to distribute it. and I get that the sine alpha plus sine alpha times cosine alpha over sine alpha. And these cancel. So what I'm left with now is sine alpha plus cosine alpha. And what was it that we were trying to prove? We were trying to prove exactly what I got it to reduce down to. So because I got these two sides to equal, I'm actually done, and I've proven this trig identity. Alright, so this looks like a good place to pick up in class because they do get more difficult, and I don't like it when my videos are longer than 11 minutes. But hopefully this was an introduction to you on how to evaluate the other trig functions. If you need more help in class, please let me know. And we will work on trig identities for a couple of classes until you guys get the hang of it. And as always, have a super day and good luck with your homework.